everybody. It is Mike Levin on Sunday, March 20th, 2022. And as you can see, I am on my way driving back from New York City to my little place in the Poconos, which we'll be moving on from in another few months as my lease is up. And I walked into a pretty sweet deal just as quarantine was locking down. I was getting out of the city, getting out of New York City, and living the country life, the mountain life. And a lot of interesting things, trampolines, zip lines, fires all the time in the fireplace, and I think I'll be keeping that. And there's a lot of benefits of the area. It does have the one downside of this long commute, mostly to pick up and drop off my kid for their time with me, and not my daily work commute, which as so many people these days, I am blessed to be able to telecommute, virtual workplaces. And I'm very thankful for that. Very, very thankful for that. I'm always working. I'm working right now. I have scripts running at home. I have a headless Chrome task running with magic numbers that I figured out so that certain processes could continue without having a CAPTCHA thrown up for me to have to prove I'm a human. So there's certain dials you can adjust figuratively in your programming code that is, adjusting, frequency, duty cycle, time on, time off, that sort of thing. Whether actions are happening sequentially, concurrently, different timing things to fly right under, shall we call it, a quota, an API quota limit. And I'm doing a lot of the stuff I had talked about in prior videos. I'm actually there. I'm doing it all. Chrome automation is like so solved now. And I find that there are really two types of Chrome automation in my world. First of all, I do it under Python. I continue to use pyppeteer, not puppeteer, although the puppeteer library is always in the picture, as is Node.js, as a mechanism to control Chrome instances. So there's quite a few moving parts, and it's the kind of stuff I'm generally opposed to. Likey, no likey, multiple potentially fragile version-specific components having to run together to orchestrate these little dances of components, which would just be so much better off if you stripped it down to bare bones components. The pip install requests is about the most I like to do for that sort of stuff. But more and more you need a browser in the picture, so it's pip install pyppeteer. And you get the bundled in version of Chromium. They bundle in a known to work recent build of the Chromium free and open source version of the Google Chrome browser into Puppeteer and by extension into pyppeteer. And you can use that. However, I find myself wanting to look like a genuine instance of Chrome. So I point the Chrome exe to where it'll find my personal instance of Chrome, the same Chrome I use when surfing every day. I set the logged in account to one of my not primary, but still quite clearly identified as me logins, because I want persistence of settings over time. So to do that, you need to log in because your settings are tied to your login. So when I automate Chrome, I'm automating Chrome operating as me, as an agent of me. I'm sending commands to Node.js via pyppeteer, via JupyterLabs. So I'm writing Python in JupyterLabs inside of notebooks, just like any other Python code. And then when I run it, Chrome opens up if I tell it to run non-headlessly, meaning showing the browser as it does things. But in either event, Chrome runs, does what I ask it to do, and then exits. And as I was saying, there's two ways of really automating Chrome. One is to load a web page and immediately make a grab for what we in the business call the view source, the actual .html code, such as it were, the stuff that lays down the initial page build. And then single page applications might kick in, and JavaScript might start executing, and images might start being loaded, and basically other HTTP calls than the original one that started building the page load. And that is often thought of as the view source, because when you're in a web browser and you right click and you say view source, that's what you're looking at, the initial HTML that is returned by the web server when a particular URL is requested. And normally in a real web browser, a whole cascading series of events triggers off, including the running of single page applications. A lot of stuff is built that way these days because of JavaScript frameworks. Load one web page, and then everything else is JavaScript within that web page to make it look like you're going places, doing things, whatever. But you're not really. The URL isn't changing, just the JavaScript app is making calls and changing what you're looking at. That isn't good enough in a lot of days. At very minimum, applications can implement what's called invisible captions. So we all know captchas. We start putting in our username, password. It wants us to prove we're human. So we have to click the fire hydrants. Another type of captcha where you don't even need to see anything pop up is just check if a web browser there by executing some JavaScript and then calling back to mama to say whether that JavaScript executed. That's kind of like a captcha, because it implies at least a web browser needs to be there, and it'll weed out things like the requests library or HTTP lib or URL lib or any of the other things in Python you can use to make HTTP calls. PyCurl, curl, for that fact, on any platform. I talk about pee in the pool of tech a lot in my videos. Curl is one of those things. Curl is worth using. Curl has a lot of application. I probably won't touch it again now that concurrency is falling into place under the request API under Python via HTTPX. I can now handle concurrency. I can do concurrent HTTP calls, which is the big draw of the thing. Hey, you want to crawl a site? You don't crawl a site one page at a time. You crawl a site 20 pages at a time. So it's sort of an HTTP call-centric mental framework for concurrency, but that's not the whole concurrency story by a long shot. Another common one is the concurrent execution of functions. Same function split up over as many channels as you want. And then the results sort of marshaled across all those channels and aggregated back to a single result. Not all work can be broken into pieces and gathered back in that way, but enough can be such that it's an important way to work. So instead of having to make 20 HTTP calls simultaneously as you would in a concurrent crawl, say you needed to, load 10 files at once off your hard drive, or the contents of 10 different lists at the same time. Now, it normally almost isn't worth using concurrency for that stuff, because at some point you're CPU bound in Python because of the GIL. But if you're using certain packages like Dask, and you're using certain APIs like MapReduce, suddenly, if it is parallelizable, it'll be parallelized, and you can do that whole MapReduce-like process, get the results back. But it's a whole lot of complexity to add if the problem doesn't really call for it. And so a lot of problems don't call for concurrency. And this automated job, this script that I have running at home right now, I had played with concurrent ways to do it. In fact, when you do things concurrently with a web browser, you're immediately faced with, what does that mean? Does that mean 20 simultaneous separate instances of a web browser, 20 instances of Chrome? Well, that's a lot of build up and tear down to do inside of like a second. If inside that 1 second you want 20 instances of Chrome, it doesn't sound wise. It just kind of sounds like the kind of thing that's going to blow up in memory, couldn't possibly be that stable. So in a browser, it's a browser. Why open 20 instances of a browser when you can open 1 instance of a browser and open 20 tabs inside that browser? And that at first looked like it was a wonderful solution. It looked like I could, at least times 5 the amount of data I was pushing through in the same amount of time. Browser automation sequential, from browser automation sequential to browser automation concurrent, a factor of 5-fold increase in speed. However, I was running it from JupyterLab, and I kept getting, well, first of all, I kept triggering the captions. So that was no good. Something about that way of working, you don't want to work that way unless you're going to go fast. And by going fast some way or another, either how many calls per second you're doing or over how long of a duration you're making those calls is going to trigger rate limiting safeguards. So why incur the complexity if you have to throttle yourself in the first place? If throttling at all is involved, you might want to consider non-concurrent behavior to get a higher degree of predictability into the picture, especially where requests per second rate limits are in effect. So I went from how to deal with concurrency with a web browser, 20 browsers at the same time, to 1 browser with 20 tabs at the same time, to even that is too unstable, let's do 1 browser at a time. The whole browser created, destroyed. Created, destroyed. Full memory cleanup. I even run a task to make sure no instances of Chrome are in memory. I use Edge so that it won't nuke my main browser that I happen to be using on the same machine while I do this, which is another story, because I plan on getting this all off of my laptop and onto my network application server. I have a NAS at home. A NAS which is running Container Station, which is a version of LXD, an LXD host. It's not Kubernetes. It doesn't have all that fancy stuff to keep 24/7 applications running at scale, virtualized. But it is quite competent at running instances of Linux, containerized, persistent instances of Linux. And boy, let me tell you, everyone who wants to promote Docker to me, I'm like listening and nodding, and at the end of them talking, I'm like, yeah, Docker, rah, rah, rah. Then I turn around and I'm going to do whatever the heck I want to do anyway, which has nothing to do with Docker. It's all LXD. LXC images running on LXD service, which is, I think, the terminology that built-in Linux containerization has finally settled on. LXC, because it's the container itself, running on LXD, because D is for a Linux daemon, right? It all makes sense. And so on my NAS system at home, my QNAP NAS system, which has undergone quite a bit of bad public relations of late because it's such a hacking target, such a malware target. But I've pretty much disconnected it from the internet in all ways except outbound requests. Outbound requests can succeed. So I can run things that can reach out to the internet, do stuff with the data that's retrieved, and process it on my NAS without the NAS being reachable by any inbound HTTP calls. I'm not doing static IP. I'm not allowing any incoming traffic to occur over any ports to my home internal network. It's only outbound traffic. So in that way, I have a place to run scripts, Python, .py files. Now I could install like Ubuntu desktop on my in a container on my QNAS and QNAP NAS. I gotta get better language for this. It's a home server. It's a tiny little home server whose keywords in marketing it happen to be the company QNAP, the device category Network Application Server NAS. But it's it's a computer. It's a computer with a couple of big hard drives in it that are mirrored, and has kind of like a modern equivalent of what some old school webmasters will know as cPanel. There used to be cPanel type web hosts real popular with WordPress people on hosts like HostMonster and Blue Dot or something. So anyway, cPanel is a nice, easy way of getting WordPress and things running. So if you have a network application server at home, you have your own little cPanel-like interface with its whole own little application ecosystem. And so when I'm talking about running Container Station on my NAS, I'm just talking about going into a website that's only accessible to me on my internal network, clicking and dragging and doing the web user interface thing, and I can have myself a little Ubuntu server. It could be an Ubuntu desktop instance, so I could go in with point and click and have the GNOME desktop, but I'm not interested in that. I run them headlessly. I run them as again, what old webmasters would know as webheads. But these days, you use these things without even running a web server on them for, miscellaneous scheduled tasks. And, so you set one of them up from a standard LXC image of Ubuntu. I'm doing 20.01, I think, or 20.04 maybe. I forget what they're up to, but whatever the latest long-term service release of the highest number of Ubuntu is. And you have to apt-get install OpenSSH server. You got to do a couple of things with your RSA keys, with keygen, for public-private key stuff. And then you need to SSH into that machine from a Windows PowerShell because of the networking context. All right, so this container I have running with network address translation. So I'm running this Ubuntu server instance on what amounts to a virtual LAN whose ports are only connected to my router's LAN. So there's two LANs in the picture. LANs is local area network. The LAN I'm on with any of my Wi-Fi computers connected to my router is the actual LAN, is the actual Wi-Fi wireless LAN. But then a virtual LAN, there is nothing, because computers are fancy things, able to make nested worlds. So there's no reason you can't make a whole nother LAN, local area network, imaginary within one of your computers, and you say, poof, this computer has its own set of IPs. This computer has a network with its own set of IPs, its own network segment. It's got its own DNS server, meaning it can get IPs from the outside world. It can do DNS lookup through internet gateway. It has its own internet gateway, etc. And this is what QEMU, on which my distribution of Linux, called Levinux, I did a spin of Tiny Core Linux plus a x86 emulator called QEMU, a PC emulator called QEMU. So with a double click, you can get a persistent Linux desktop on the desktop of a Mac, a Windows machine, or another Linux machine. It was very cool, very ahead of its time stuff, just connecting the dots of other people's tools. But then along comes Jupyter Notebook and then JupyterLab, and it, in spirit and essence, is doing the exact same thing. It is your path to cross-platform code portability. It's a way to host Python.exe. And it rapidly elevated itself in my mind to more important to me than my own Linux distro, because it achieved what it did much more pragmatically, much more effectively, much more useful, much more high performance. And the results of the work is much more liftable and putting into a traditional Linux server easier than, I guess, moving it from Tiny Core Linux. It's just too radically different. Not that radically different, but it's like an embedded Linux, that you put on an x86 architecture. So you feel like you're using these really, really tiny versions of Linux, 8 megabytes, 10 megabytes, not gigabytes we're talking about, 10 megabytes, right? Tiny Core Linux fits on a single floppy in some cases. And there's other versions of it. The version of this kind of Linux that has become massively embraced by every one of you, you're all running it, except for you Mac users. And AMD has something like it, but not exactly. But on all Intel machines out there, you're running Minix. You're running a version of Unix that you don't know about called Minix. And it's one of these very minimal mix systems. So I like them. They're like little full-fledged general-purpose computers on a keychain. Tiny things that make you wonder why you're using all this bloated overhead of whatever desktop operating system you're using. There's a few versions of Linux out there that still maintain this in spirit. Of course, they're the ones that don't use systemd, the monolithic system management piece that I'm advocating learning, so that you can do general purpose things on Linux, like scheduling. But the small, tiny, snappy, high-performance versions of Linux that still have this old-school approach that don't favor desktops at all is Arch Linux and Gentoo, or Gentoo, right? Tomato, tomato. But Gentoo Linux and Arch Linux still carry on this old-school tradition. Desktops are frowned upon. You don't really need it. Their equivalent in the Unix world would probably be FreeBSD. Sure, there are desktops, but really, what do you need a desktop for if you're just running a bind server for DNS? So, where am I going with this? All words. Where did I even start out? What was the topic that I got started with on this? Definitely it went to Python, and definitely it went to it being the interoperable language. Of course, obsolescence resistance and obsolescence proofing, disruption resistance. These are constant recurring themes in what I talk about. But this one was opening up, talking about, I remember distinctly, two separate ways of Endless Chrome being part of my everyday toolkit. Oh, 2 ways of automating Chrome, for sure, that was it, yeah. So one way is just grabbing the view source. That's what I'm doing. It's so easy. There's no Chrome automation, per se. You're just invoking Chrome. You're saying, load this URL from my actual version, my actual everyday version of Chrome, so that it looks like me surfing. I don't know if, well, yeah, actually, Chrome itself gives you a message that it's running in automated mode. So something about it knows that it's running in automated mode, and it could send that up on the HTTP request. So I gotta investigate that, whether Chrome being in automated mode advertises to the servers it's talking to that it's in automated mode by virtue of anything in the HTTP request. I will look at that. I will look into that. Because, you know, in programming your robots, it's coming down to everyday use, right? I was talking about how pyppeteer is how I'm still doing it, because for whatever reason, it's matured and stabilized there. Against all odds, the unofficial library is where it's all reliable at this point for me. And the new library, Microsoft Playwright, which claims to support Python as a native client library language, which Puppeteer doesn't. Pyppeteer is not official from Google. Puppeteer is official from Google. Puppeteer is an NPM installable JavaScript library, client library, to control Node.js, to control Chrome. So all this overhead. One of the places I was going was all this overhead is still less overhead than the alternatives. Selenium is more overhead, and Selenium won't get you genuine Chrome. It'll get you Chrome driver.exe, and what's that? You can't show it headless. You can't turn headless operation on and off and watch it surf. I don't think. Maybe you can, but you certainly can't, you know, right-click with the inspector and use Chrome dev tools to help in your automation tasks with Chrome.exe. It's not the real Chrome. It's not the Chrome that Google itself sends out as part of the Googlebot process. So Google's own crawling of the web, crawling and indexing the web, is, you know, done now. It doesn't use the view source like it used to. It wasn't the old Googlebot that just has access to only the HTML. It is now the same Chrome that you and I are using to surf the web is what Google uses to crawl and index the web for search now. So you want to be using that too. And if you're going the distance to do that, you might as well be able to control all the web browsers and emulate different platforms like mobile and all the different mobile platforms. So it's looking more and more, if Microsoft keeps their promise, that it's going to be Microsoft Playwright. That Microsoft Playwright is going to offer Puppeteer compatible, asynchronous, you know, biased towards asynchronous mode automation scripts. So they're also providing a non-synchronous Python API for browser automation. I keep making this point, but every time I try it, it doesn't work. It doesn't work from Jupyter. It doesn't work from JupyterLab, which continues my belief that Jupyter is somehow being monkey patched to allow the miracles of pyppeteer automation with all its event loop manipulation to actually work. It shouldn't work. It shouldn't work. Going into async mode and then coming back into non-async mode in a script. The first time you use async as a keyword, it is my understanding that the whole script is now in async mode. You can't go back to using non-async things beneath it. But I find myself to being able to do that. So I find myself worried that anything I create that way in Jupyter is not going to be able to be moved over to headless automation. I have concerns now. So what I'm doing is I'm using my NAS, my home server, to set up headless Ubuntu servers. I call them servers, but they're going to be running batch scripts. They're SSH servers. They're hosting the SSH server. I can SSH into it. Then I'll always add, if they don't have it already, the screen program, apt-get install screen, part of the standard GNU commands, but not always included for bare bones purposes. It's one of those, if you don't need it, don't really install it, because not everyone uses it anymore. A lot of people use tmux, so why install screen? But screen is part of the GNU command set, tmux isn't. So I've been getting used to screen. And so in addition to the open SSH server to get into your container, you also want to install screen so you can have terminal sessions so that the scripts you run on your containers are not in fragile SSH terminal sessions that when you close them, the script stops with it. That's the first thing you got to overcome once you have SSH access to your own, say, containerized Linux system. You want tmux or screen. Screen is more standard. I use screen. Once you have screen, you can launch as many terminal sessions. It's just like terminal server viewer from Windows, but no graphics interface. It's terminal session to true terminals. Type in Unix style terminal shells. But you have as many of them as you want. They run independently from each other, and they don't close when your main SSH connection is broken from you closing, Xing out, timeouts, or what have you. So when you have long-running scripts, you can walk away with confidence. It's very important in this kind of work. I would even say this is really important in machine learning work. Lots of long-running scripts on lots of headless instances of servers that are under your control. This is really a place where you want Saucer's Apprentice type power. The ability to make lots of brooms pop into existence and do your bidding, like Mickey in Saucer's Apprentice. And then there's questions of how much knowledge and know-how of the underlying Linux system do you really want or need to have in doing this? Systems like Heroku, cloud service systems, insulate you from the Linux underneath. They insulate you from the infrastructure, and they don't really provide infrastructure as a service so much as they provide platform as a service. So you'll hear these different terms thrown around. IaaS, infrastructure as a service. That's what Amazon back in the day was known for. That's what the Elastic Computing Cloud was. But now they have more types of services than you can even count, right? So from Lambda to S3 to various types of databases. If you want RDBMS, they've got a Postgres-derived thing called Firebase. If you want NoSQL, different from the Amazon S3 store, which is great for large blobs of like video, like Netflix would be built on that. But if you want quick, snappy key value stores, more like Google's Firebase, which has become popular in recent times, Amazon has their own key value service. So there's every kind of web service, and they all try and insulate you from implementation details and get you used to their nuanced way of working. And that locks you into cloud platforms. You can build it yourself. You want one kind of database, you run Redis. You want another kind, you use CouchDB. You want another kind, you use Postgres. Now you got to become the DBA, and you got to incur the tech liability and the tender love and care of that yourself. But you don't have to pay cloud services every time you run it. You get it running on some local machine. You get a few GPUs, model stuff out, make sure it runs locally, prove it out locally, rerun it as many times as you want, costing you only the electricity. But then you can do times 1,000 when you want to by employing the cloud. If you base it on, cloud employable APIs And that's why PyTorch and Fast.ai are becoming much more popular in recent times than Google's TensorFlow approach, because TensorFlow starts to lead you to using Google's specialized tensor hardware in the cloud, and cha-ching, cha-ching, it's all about timeshare. It's all about charging you for use of centralized elsewhere resources, when your local resources can be quite powerful enough to keep you from paying those cloud services according to the 80-20 rule. You save yourself 80% of the cloud money you would pay to cloud vendors by investing the first 20% of money you could see yourself paying for hardware. So you get some modest local hardware with some killer GPUs in it, and you use PyTorch. And you don't pay anyone a cent as you work stuff out on your machine learning, vet your ideas. And then what you have will be 100% portable to the cloud, not locked into any cloud vendor, and scalable at home if you want to do it with your own or rented GPU, hardware. So anyway, that's a little bit of a tangent. What was I saying? There's two ways to automate Chrome, right? One way is to grab the view source and run. And that's good when you're doing certain types of scraping jobs, screen snapshots, what have you. You don't care about interaction. You don't care about extracting JavaScript values on the screen as opposed to view source HTML. If you see a number in a table and you try and grab it out of that location in the table and it's not there, well, you got to execute the JavaScript. And in that case, it's not just grabbing the view source and going, but it's reaching into the document object model and grabbing values out of, according to paths. And the choices, if you want your life easy, there's a CSS selector path. But it's not always so easy. When it's not so easy, there's an XPath. When XPath doesn't work for you, you can use jQuery paths. When jQuery paths don't work for you, I don't know, some other thing. So there's lots of ways to reach into the JavaScript rendered document object model to grab JavaScript values. So that's a second way to interact with Chrome as it's going. It's still mostly a scraping model. Shall we say a third way? I said there's two ways. And these second two ways are both really under the same umbrella because you're interacting with JavaScript. If you're not just grabbing values, you're doing control. You're setting menu items, you're plugging things into search fields, you're hitting submit buttons, you're paging through results, you're clicking export buttons, and you're basically doing user automation, recording and playback of user actions, but without all the screw-ups because you're addressing things by exact locations, and your timings are worked out by wait for this element to be available. So your timings don't get screwed up, and your where you clicks don't get screwed up because of addressability and deterministic aspects of waiting for elements to be there. You avoid race conditions, and then you create fragile, still GUI oriented, even though you don't have to care where you click. The GUI, if the GUI changes, it breaks. But if an API changes, it breaks. It's all the same. It's all the same. Whether you're automating interactions with a web user interface to pretend you're a human, or if you're using all the nuanced details of some kooky API. It's just as hard as pretending you're a user in a web browser, I've learned over the years. Kooky APIs are no easier than browser automation. Browser automation is just another API. Don't pinch your nose at Chrome automation as a primary API. It's fine. It's a great way of grabbing data. And all the things that webmasters do to serve up structured data on web pages, for pricing availability or what have you, you can take advantage of that too, because that structured graphics is available to you in the DOM. So applications are limitless. And it's just part of now the plumbing of tech. It took me a while, it really took me a while to accept that browser automation was part of the new plumbing of tech. It took me a while to accept that browsers were part of it, that the web itself is part of the new plumbing of tech. And I really dissed the web in prior videos, saying that the whole significance of the whole web thing, web browsers to HTML and CSS, the whole works, is no more important to tech in the big picture, in the long-term sense, than regular expressions and SQLite, insofar as their ability to be embedded into meaningful host environments like Python. So, when you embed a meaningful web environment into Python, you're pip installing puppeteer, and or pyppeteer. There's going to be something like pip install pyppeteer forever forward now. Pip install Microsoft's version. Playwright. So, it's not going to be part of the standard library for a good long time. But web servers are. There's a web server built into Python. There's just not a web browser built into Python. But I think Python might ship with the TK GUI, web GUI user interface. I know that FreeCAD is built greatly on the Qt user interface. I believe that's the user interface that was originally proprietary. I gotta look this up. I keep mentioning it in my videos. But talking about P in the pool of tech, eventually the web browser will be. But already even Qt, the Qt user interface, is more built into Python for user interface work than the web is. But the web is clearly a more universal user interface standard now. And it's only just barely usable as a primary user interface for building apps. And does Node.js have to even be in the picture? Does it have to be this bloated JavaScript picture? Well, no. In true Python form, there's ways to strip out almost everything except for Python and the minimal possible components needed to talk to I guess the modern equivalent of a whiskey server, the Web Common Gateway Interface. CGI, people who date back to, the web, meaning having a CGI interface so that you can run Perl scripts, that was CGI. And then when Python standardized how it wished to do that, it got the moniker WSGI, which people started calling whiskey. And now that all that stuff needs to be reprogrammed to support the async IO library and the async await keywords, it's no longer whiskey, it's the asynchronous version of that, the asynchronous GI, asynchronous gateway interface or something like that. So that's now ASCII. So we have another ASCII to keep straight between the ASCII text and ASCII standards, and there's now ASGW, I don't even know, but it's the asynchronous web server that is, I think, built into Python. I'm not entirely, no, I don't think it is. I think the whiskey, there's a default whiskey server, but you still might need to pip install something to get the asynchronous version. But I know that one of the versions out there is a riff on GNU-icorn. There used to be GNU-icorn, the GNU version of Unicorn, which was a whiskey server. And what is that? That's something corn, Unicorn. It'll come to me, not in time for the video. But Python, begrudgingly, over long periods of time, allows things into the library that fulfill the criteria of P in the pool of tech. Again, regular expressions and SQLite are preeminent examples. Having a built-in Whiskey web server is another example. Yeah, so it's going to be a long time before a full Node.js instance is included with Python, but it is so wrappable in Python. It's just a perfect example of what is always done in the Python world when something superior, or at least exists in some other language's world. We wrap Hadoop, we wrap Sparks. I think Sparks was one of the wrapped APIs, one of the great wrapped APIs. We wrap Elasticsearch. So everything of great use that comes from, the Java world in particular, the JavaScript world more and more, is accessible through Python by some wrapper. And that's how Selenium was available, unbeknownst to so many people, that when you were doing Selenium under Python, which looked so clean, looked like it had so little external stuff involved, was really installing the whole Java, stack, and a bunch of other little components, big components, which gave Selenium its reputation for flakiness and non-mainstream browser support. Phantom.js, I even tried that for a while. I kicked the tires of almost everything in these neighborhoods and then went running for the hills, because if it isn't ready for prime time, or if at least it's not, I don't need it ready for prime time. I want the bleeding edge to be quite not so bloody. I'll live on the bleeding edge begrudgingly. After my experience with the Amiga computer, after that platform abandonment of the Amiga computer, after the platform abandonment of Microsoft Active Server page, and after the attempted coercion to get me into Active Server page .net, ASP.net, which is not ASP at all, oh my god, let me tell you. After the coercion to try and get me into React, and even the coercion to get me into Vue.js, which is slightly better. I tried Angular back in the day as well. I do recognize Vue as in the lineage of Angular and not quite as objectionable as React and Redux. However, I have a vomit reaction to all of it. It's all disgusting to me. It's all terrible, bloated, fat overhead tech that moves things to where you have... It's like the monolithic component versus micro-kernel or microservice components. You will find lots of legitimate arguments that microkernels, which Minix, by the way, is the split between Linux and Minix, the split between Linus Torvalds and Andrew Tannenbaum, where Linus inherited the Wild West of web servers. Andrew Tannenbaum inherited the secret invisible hand operating system that's on all your computers that manages all that sleep state. Why does sleep state work so well? Because there's a whole nother low power OS ensuring that sleep state works well even while your computer's asleep, that has a full network stack, so vendors have the ability to do anything they want with your hardware, just so you know. So Nix in general wins. General generic plumbing of tech exists. It all exists in that whole teletype-based interface, TTY, that goes under so many non-unified names and has so many sub-flavors. Like when we say bash, it's the Berkeley version of the Ash script. And the Ash script is yet another shell. So the Berkeley version of yet another shell. And then there's Born Again shell. The word wordplay is endless and recursive. So right when you think you get to the end of clever wordplay in Unix/Linux program naming, and you get right to the bottom, you find out the bottom is a recursive reference. GNU is not Unix. That's what GNU stands for. So I feel like after 50 minutes, I'm almost just rambling here. I've talked a lot in the past about Chrome automation, and boy, oh boy, what pushed me into it the most recent time. I mean, yeah, I'll just outright say it. Those of us who are in the field, and it's almost an hour in, so I can talk about what that job is that I'm running at home. For those who stuck it out this long, you deserve to know. I'm SERP scraping. I'm running searches against Google as a user. It's me. I'm proving I'm a user. It's a real human being. I'm doing it at exactly the rate that's plausible where it could still be a human being. And arguably it is me doing it. I expressed it. And it's running in Jupyter. It's running in JupyterLab. I need to start saying just JupyterLab. It is a Jupyter notebook because it is a .ipynb file, no doubt. It's a notebook. But the notebook that's running, the execution environment, is JupyterLab. JupyterLab is on the verge of changing the world. And again, 50 minutes into this video, I'll make one of the key points. It's so important. One of the commenters in the video said, "Why do I like Jupyter so much?" Well, it's because there is a story. There is a Python installation and growth story. How do you first use Python on your machine? And then how do you continue using Python on your machine? And how will you be using Python on your machine and many machines beyond yours in the future, right? Because if you're using Python well, you're going to be using Python on more than just the machine you start out on. However, I emphatically emphasize emphatically and redundantly restate, you should avoid relying on the cloud to execute your Python code. While Microsoft Notebooks and Google Colab and Binder are all wonderful tools, each one with its own separate strengths for, collaborating with Jupyter Notebooks on the cloud, none of them are going to let you understand the hardware issues that you really need to start understanding. None of them are going to let you feel the local files at the full speed and not having to have network latency issues like running local. So one of the neat tricks I'm doing with my container running on my QNAP NAS is having a shared location. Now I was wondering where my I'm running Jupyter on my laptop. I'm running Python in a container in a separate server over there. Where should my common hard drive be? In the container? Containers traditionally aren't great for persistent hard drives. I have it because I'm using LXC over Docker, so luckily I can have persistent hard drives without, stupid Docker tricks, composing, mapping in external. Well, I'm mapping in an external drive. One way or another, you're mounting a drive from you're giving a drive that exists elsewhere a mount point. But happily, LXD accommodates for that. So I map in a network drive when this thing is created, when this container is created. First, I tell it to run in privilege mode, just in case I do want to use network file systems or common internet file systems, CIFS. So, and it's all under SMB. So SMB started as Samba, but Samba is so Windows-like, no one really tends to use it much. So there's a few new services that are on the pike that claim to be more operating system agnostic, and those are Common Internet File System, CIFS, and Network File System, NFS. But to get any of those working with your container needs to be running in privileged mode. So I wasn't, and were I running in privileged mode, I would probably be talking about how to get a network drive mapped into a LXD container right now. But I'm not. I'm talking about using what must be, and I'm speculating here because I'm not 100% sure, LXD's ability to map a network drive into a container at a lower level without special software running on the container. The containerization software itself, the LXD part, the part that gets your containerized Linux instance running, also gets to say, here's a network drive that I have access to as your host machine. The host machine has access to it. See, my Windows 10 host has access to this NAS location. So, well, it's not even the Windows 10 host, it's the host machine of the NAS. The NAS is the host machine. The host machine says, I have this local NAS location. That's what I do. I'm network application storage, network application server. So here is //location : drive or subdirectory, something like that. There's a protocol, a universal network protocol. There's two different ones. I've seen at least two different ones, but one of them works with mounting LXD containers so that you've got your upper level, your parent NAS, the NAS that's hosting the container that also has hosted storage, is making the hosted storage available to the hosted container. The hosted container does not contain the hard drive. The hosted container has access to the hard drive, which my Windows 10 machine also has access to because I mounted it the way Windows 10 mounts NAS locations. So that same NAS location is mounted for my Windows 10 machine. It's mounted for my container running on my QNAP-NAS. I have a common hard drive. Lots of words, blah, 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 blah. I have a place that my Python scripts can write to in Jupyter Notebook. My notebook scripts, my JupyterLab IPYNB notebooks can write to SQLite.db files, although they don't need .db extensions. It seems one of SQLite's favorite tricks is to not use a DB extension, so you can't identify it as a database on site, on file name site. I think the Mac does that a lot, and probably even the iPhone. But by convention, I use a .db extension on my SQLite files. If I use SQLite dict and the context manager with SQLdict filename.db on the NAS drive, so it would be location to the NAS drive, filename.db under Jupyter Notebook, that same said filename.db is now accessible to me from a headless Linux server on which I can do scheduled tasks. I wish I had it at the beginning of the week and I could have doubled up the speed I was running this job. But the thing I'm going to do now, the really exciting thing, the assurances that I need to give myself, is that I can run Chrome headlessly on a headless Linux lightweight Ubuntu 20.04 LXD container. Simple enough, right? It's starting to come off simple in my head. This stuff needs to get into your muscle memory. It needs to stick. And I've been with virtualization from the beginning. I was virtualizing Macs on the Amiga. I was virtualizing the ColecoVision on the Coleco Atom, right? So Zilog processors, right? Mikey goes back quite a bit. I was using the old Motorola 68,000s. I'm not as old school as to be on the 6800s, but I was on Zilog processor machines. Those are Z80 processors, which were competitors to 8080s, eventually 8088s, eventually 286s, 386s, eventually the whole x86 architecture we know of. That came from Intel, and the Zilog, the Z80 processor, is to the Intel lineage what the Commodore or MOS 6502 lineage of processors was to the Motorola 68,000 lineage, and 6800 before it. So when things were in the hundreds, Motorola, sort of like RCA, the television people of yore, actually came out with some cool chips. And they were the 6800 chips. They were still, $250 a pop. So a competitor came out, the MOS 6502 chip. 6501 first, but it impeded on intellectual property, so Chuck Peddle black boxed more parts of it. It became the 6502 chip. On the other side, so that's the Motorola side, which spawned the Amiga, the Macintosh, some models of the Xboxes, the I think it's called the Scale architecture, the Cell architecture, Power PC, whole bunch of stuff in that line. But the other line was, when it was in the hundreds, it was the 8800, 8600, 8800. Then it became the 88,000. Then it became the whole Pentium, the Intel Classic x86 architecture, AMD included. So that was a big split there between two different architecture types. I've been on both. I've bopped back and forth. When ARM came on the picture, I was on early Palm Pilots. I was not on the Newton. I was not on the Apple Newton. I got to admit, I was not on one of the earliest computers to have the ARM architecture. So ARM helped fund, Apple helped fund ARM, even though ARM sounds like mostly a British story, and if you really stretch it, a British plus MIT story because of the open source RISC architecture that I think was called MIPS back in those days, that inspired, but, was not the whole story behind the ARM architecture. But, the Brits unsatisfied with doing it the American way. Which $250 chip do you use? Oh, neither one. Okay, which knockoff chip, the Zylogs or the MOS chips? Well, neither one. We'll do ARM. We'll just invent our own. We'll call it ARM. We'll do some better graphics stuff than Commodore did, because Commodore had to break out all their graphics and all their audio processing into graphics and audio co-processor subchips, the SID chip and stuff like that. On the Amiga, it was the Blitter chip. So, in the UK, they just all put it on the ARM. They put it all on the ARM chip, and it was remarkably low power, and that became a third major processor lineage path. There was the Motorola, there was the Intel, and then there was the ARM, and little did anyone know there was ARM until it took over the world in vectors that people didn't even understand. People didn't understand what, the Snapdragon processor was and the Cortex processors, but, it's a third very distinct lineage of CPUs that was growing up around the mobile, low power consumption computers that we call smartphones, and other kooky devices before it, like the Palm Pilot, the US Robotics Palm Pilot, and the Apple Newton that was much maligned, handwriting recognition. Oh, so where the heck was I going with all of that? Different ways of doing stuff. Oh yeah, it all started from Chrome automation. Alright, so I'm getting close to home, and this long rambling video needs to be wrapped up somewhere with a sharp edge point on it, because I know I start out on specific points. I start out talking about my current work. I get wrapped up in the sub-details, the little idiosyncrasies that exist in making these miracles happen. The fact all this stuff is happening is just friggin' miraculous in the first place. Flipping Chrome to headless mode and all the questions that invokes, and how headless can it be. So I'm going to find that out. I'm going to move it over to a very minimal Ubuntu 20.04 headless Linux server running containerized, not Docker. Everyone wants to say Docker, but this is one of the 2 points I'll make. One is on the virtualization of preferred virtual machines, which are your preferred APIs, which is where your preferred obsolescence resistance resides, which is why I reject, which leads to the second point. So preferred virtual machines is the first point. It's always about what's your preferred virtual machine. What's your Noah's Ark? It's never not going to be a Noah's Ark. There's no technology you can take up where you're so close to the metal and you're so leading edge that they're not going to have to containerize it so you can get those same abilities 5 or 10 years down the line. All technology becomes obsolete and containerized. So what you're going for is, what's my favorite flavor of containerized obsolescence of a virtual machine? I say Python on any Nix-like host operating system. And that's been such a huge point of my videos and my ramblings of late. But then the other thing is, so it's all about containerization, and then which APIs are gonna, become favorite obsoletes. And that has to do with hardware platforms. It has to do with the idiosyncrasies of various hardware platforms that are going to be carried over and made scalable and instantiatable and become common units of computing. Intel is trying to, or it might be IBM, one of them is trying to appropriate the terminology surrounding standard unit of computing. I believe Intel NUCs, NUC, which were their answer to the Raspberry Pi. It's like, hey, when you're Intel, you too can do the Raspberry Pi, but ours can fit on the size of an SD card. A whole Raspberry Pi on that, a whole x86 architecture or whatever architecture. And so what's a rack server? A rack server is SD cards lined up in a row in a little thing about, the size of a stick of gum. It can be a rack server of little NUCs. I know there's bigger size NUCs, and it's reminiscent of the concept of puck, like a hockey puck. So a NUC is about the size of a puck. It's a nice standard unit of computing. We see lots of things show up that size. Apple TVs have shown up that size. And in a way, Chromecast is kind of that size. And that size, I think, is disappearing. Fire Stick, it's nice, but you can fit so much computing into such small spaces. It's just going to disappear as a thing. It's going to be smaller than the port it gets plugged into. So that's what's happening with the SD size ones, and that was stuff from like 10 years ago. I was reading those articles. Honestly, a fairly capable server can be fit on a grain of rice, I would imagine. And one always must remember that, in the same sense that a version of Minix is installed on every piece of Intel hardware for the past 10 years. Complete web servers can be in your smart light bulbs, calling back to the homeland that they were manufactured in, using encrypted burst communication that'll look like just random noise on your network, so even network sniffers might not be able to pick it up. So always just be aware that no passwords are secret, because a network sniffer like that could grab all your passwords, or at least have all your recent tokens, authenticated tokens, in some server somewhere that's collecting and harvesting all usernames and passwords in the world, because smart light bulbs could have grain of rice size, network sniffers in them. So one must understand technology has been at that point now for a good long while. 5 nanometer manufacturing scales for transistors on integrated circuits means that the land of Oz is upon us. Magic is real. No human being can understand the complexity that goes into these systems, but the systems can have kind of a low power consumption and a kind of robustness and almost self-healing to them these days that can keep them running in hostile environments for a very long time. Reporting back to mama with, opportunistic network stacks that work in encrypted bursty mode and have other kinds of sensors that you may not be aware of in there. Certainly location sensors are a possibility. Cameras and microphones, too small to see. Cameras need surface area exposed for some sort of lens, but audio, you don't even know how audio can be picked up through surfaces, through induction, vibrating surfaces. So I don't want to turn this into a paranoid video, but I guess I already did. I'm going to keep the video even though I went there in my mind. Let's back up a little bit and just put that fine edge on the video before I wrap it up. We're at 1 hour and 10 minutes. Vendors want you to invest all your time into APIs that they control, that are uniquely tied to their services, their tools, and they don't mind it going obsolete on you because it's no skin off their back. It's just more money in their pocket from new product purchasing cycles, new retraining, new recertification, new equipment having to be purchased, new code bases having to be modernized and replaced. That is in their interest. Vendors want that. Free and open source hasn't really been on the scene for that long solving this problem, but it has been on the scene for a little while solving this problem. These bandwagons are very hard to identify. I must have been exposed to Python 2 or 3 times in the past before I finally gave in. It was putting up a smoke screen that I resisted. Who wants to use a language called Python? I am not a Python person. Deep inside of my heart and mind, 2 beings walk the lane. One is soft and gentle, the other's hard and vain. One we call yin, and the generally attributed to the feminine spirit, although I don't want it to be gender labeling, but traditionally where this duality has occurred, the softer, gentler, wooder, round elements are attributed to the feminine, also stormy and unpredictable. And the more sharp and linear and, throbbing python of love, as Robin Williams had once put it, attributes are attributed to male. The masculine gender, the more predictable, the more linear, the more optimizable, the more green versus blue. Yin is more blue in spirit, yang is more green in spirit. Green and shiny versus blue and fuzzy, right? So I resisted Python because I was I continue to this day, blue and fuzzy. I'm a blue and fuzzy with red armor. I'm a version of a green arrow that's not really a green arrow. I'm an old softy existing in a green arrow world. And I do it because I thought that's what I had to do. I believed that's what people had to do. But it was not true. But now that I've gone that route, I make the best of it. I make the best of it because Python is not anything like what I thought it was going to be when I started out with a name like Python. It's because Guido van Rossum was, choosing a name, and he might have done it subconsciously. It was named after Monty Python, a quite distinctly, yin, blue circle comedy troupe, as opposed to more like the linear yang comedy type people, more American in spirit, more snarky and Chevy Chase in spirit, Saturday Night Live in spirit. Round is very indirect and very cross-dressing, shall we say. Everyone who watches Monty Python knows what I'm talking about. And that's where a lot of technology innovation comes from. I'm sorry. It's just true. You look back over the, pivotal, seminal, changes in infotech, in computing, and you'll find it. And it changes things. It changes ways of thinking. But people will reject it. People will reject it for very long periods of time because it's not the orthodoxy. It's not the computing orthodoxy. It's not what's taught in comp sci classes. But eventually, Linux, the distribution, the people who put the distributions together yield to pragmatism. They dump the Perl programming language, which no comp sci department in its right mind would base itself on, and they pick up the Python programming language, which is 80-20 rule good enough to teach comp sci. So out of convenience, it's part of the default install of a lot of things. There's a good install story. I'll get back to the Jupyter install story about why Jupyter's changing the world, and then that's where I'll wrap it up. You got a good install story, you got a good enough language, you got comp sci departments switching from Scheme, the Scheme dialect of Lisp, and sometimes Java, and less so, but still sometimes the C programming language. For the comp sci departments, switching to Python. It's a pragmatic choice, a pragmatic language. And then all those old Luddites, all those comp sci snobs have to give in because Python is used more and more places. And I was one of those people who gave in because Google used Python to such an extent. Their original compute engine came in either Python or .NET, Java. I guess maybe 3 platforms. Java, .NET, and Python. How could Python be a third? I didn't understand that, so I gave it a chance. I took it up and never looked back. It was as good as the people who tried to get me to turn to it years prior had made it out. I guess I have regrets I didn't, but I had to be ready for it. I guess I had to come to be ready for it. And that leads to this last point. There is still no great path to Python on Windows. For the beginner, for the noob. Standalone Jupyter is almost it. The install story needs to get better. And if there are Anaconda licensing issues, those need to be dealt with because it was unacceptable licensing on Anaconda. I dumped it over that. Anaconda pushed me to standalone Jupyter because of the way they changed their licensing. I hope that Jupyter, using bits of Anaconda, doesn't incur all that same licensing. But I have confidence they'll work it out. I like the Jupyter organization more than I like the Anaconda organization. And all I need is Jupyter. I thought Anaconda was bloated in the first place. I think Jupyter is bloated too, but bloated in a more acceptable way. And it is gradually in my mind becoming pea in the pool of tech. Well, at least in my own world. It's becoming fundamental. It's becoming almost irreplaceable because of the way the REPL environment works, interactive exploratory programming. And so as soon as the Jupyter standalone install can keep itself updated, or the update method is easier, then the path to Python for noobs is crystal clear on Windows and presumably on all other platforms that support standalone Jupyter. And that's when the tides are really, if people think that Python has come a long way up till now, wait until the Jupyter notebook install and upgrade process is easy, when there's that, I guess, Electron app just updating itself underneath of you. I guess that's the hard part. Maybe they shouldn't be on Electron. Maybe they need to find another way to make well, anyway, that's a whole nother video. I'm just about home. Jupyter Notebook. Jupyter Notebook has changed the world. JupyterLab standalone version is going to change the world in even greater ways because it's providing a learning environment for Python that will take you as far as you need to go. And my current work right now is, blasting the pipes out of that seamless transition of very large SQLite databases being shared between both sides. The sides of, headless Linux automation servers and very web browser point and clicky like local desktop Python versions via Jupyter. Whew. And I guess that's it. Thanks for joining me. Hope to talk to you again soon, and don't forget to subscribe.